In Lesson 10, we'll be reducing and comparing fractions. When you reduce a fraction, you're trying to change your fraction to an equivalent fraction that has a smaller numerator and denominator than your original fraction. In lesson 9, we found equivalent fractions, but we built up our fractions. We made our numerators and denominators bigger by multiplying each of them by the same number. While in reducing fractions, we will be making our numerators and denominators smaller. Remember, as you're viewing Lesson 10, if a concept or a problem is not clear to you, stop the tape and go find some help. Reducing fractions. As I just told you, we reduce a fraction when we change it to an equivalent fraction that has a smaller numerator and denominator than the original fraction. A fraction is reduced to simplest terms when the numerator and denominator have been made as small as possible. So when we reduce a fraction, we try to change the numerator and denominator to a smaller numerator and denominator. And when we reduce it to simplest terms, we try to make the numerator and denominator as small as we can. But our new fraction has to be equivalent to our beginning fraction. To come up with an equivalence fraction that has a smaller numerator and denominator than our original fraction, or in other words, to reduce a fraction, we're going to use the fundamental theorem of fractions again, but this time we're going to be dividing the numerator and denominator by the same number. When you multiply the numerator and denominator by the same number, you build up your fraction. But when you divide the numerator and the denominator by the same number, you come up with a new fraction that's equivalent to your original fraction, but in your new fraction, your numerator and denominator are smaller. Now when you divide, you have to make sure the thing you divide by is not 0. We can divide a fraction's numerator and denominator by the same non-zero number and obtain an equivalent fraction. For example, look at the fraction 12 fourths. We can divide 12 by 2 and 14 by the same 2 and come up with a new fraction that means the same thing, 6 sevenths. So 12 fourteenths and 6 sevenths are both equivalent to each other. 6 sevenths is the reduced version. If you wanted to go backwards, you could multiply the 6 by 2 and the 7 by 2 and get back to your 12 fourteenths. When we're reducing fractions, we're going to be doing a lot of dividing. So it will make our work easier if we can look at a number and tell when it's divisible by certain numbers. There's some pretty easy divisibility tests for the numbers 2, 3, 5, and 10. So I would like for us to talk about those to give us some hints in our reducing. First of all, let's talk about being divisible by 2. A number is divisible by 2 if it's an even number. Now what even means is that the last digit is 0, 2, 4, 6, or 8. So if your number has a last digit of 0, 2, 4, 6, or 8, then it's divisible by 2. So let's look at some examples. Let's look at these two numbers and decide whether or not they're divisible by 2. We start with the 965. The thing that tells us whether it's divisible by 2 is the last digit. So let's look at the last digit. To be divisible by 2, the last digit has to be a 0, 2, 4, 6, or 8. Well, in this case it's a 5. So it's not divisible by 2. In other words, if we divided 2 into that number, we would get a remainder. So it would not be divisible by 2. Let's look at the next one. 398. Its last digit is an 8, so it should be divisible by 2. Since it ends in an 8, that makes the number even. Last digit, 0, 2, 4, 6, or 8. So therefore this one should be divisible by 2. What that means, and we'll check to make sure it works, it means that if we took 2 and divided it into 398, we shouldn't get any remainder. So let's do that. 2 into 3 goes 1 time. Bring down our 9. 2 goes into 19 9 times. 9 times 2 is 18. Subtract and get 1. Let's get where we can see this. Subtract and get 1. Bring down our 8. 2 goes into 18 9 times. 9 times 2 is 18 with no remainder. So 398 was divisible by 2. Now let's talk about the rule for determining if a number is divisible by 3. A number is divisible by 3 if the sum of its digits is divisible by 3. So let's look at an example. Let's look at the number 444. Now it's hard to look at 444 and know whether it would be divisible by 3 or not just by glancing at it. But what the rule says is the sum of 444's digits has to be divisible by 3 in order for the number to be. So let's take the digits. 4 plus 4 plus 4. If I add those digits up, I get a 12. And 12 is a number that's divisible by 3. So since 12 is divisible by 3, 444 is supposed to be divisible by 3 also. So let's check and make sure it is. Didn't leave myself much room to work that, but 3 goes into 4 1 times. 1 times 3 is 3. 3 goes into 14 4 times. 4 times 3 is 12. 3 goes into 24 8 times. 8 times 3 is 24. So 444 is divisible by 3. We didn't end up with a remainder. Okay, let's look at another one. Let's look at 521. If we add up those digits, 5 plus 2 plus 1, we come up with 8. 8 is not divisible by 3. So according to the rule, 521 should not be either. And let's check and make sure we see that 521 is not divisible by 3. 3 goes into 5 1 time. 3 goes into 22 7 times. 3 goes into 21 3 times. 3 goes into 11 3 times. 3 times 3 is 9. And you see we have a remainder. So the 521 was not divisible by 3. Because the sum of its digits was not divisible by 3. The 444 was divisible by 3 because when you added up the digits, you got 12, and 12 was divisible by 3. So to tell if a number is divisible by 3, you add up all the digits and see if what you get is divisible by 3.